June 12, 1943. Capoterra Airfield, Sardinia. The distinctive twin-boom silhouette of a Lockheed P-38 Lightning descended through Mediterranean haze, its Allison engines settling into an idle as the wheels touched Italian concrete. American pilot Second Lieutenant had meant to land at Malta. His compass had failed somewhere over the sea, transforming what should have been a routine ferry flight between Gibraltar and Allied territory into an inadvertent delivery of one of America's most advanced fighters directly into enemy hands. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Italian ground crew personnel froze momentarily at the sight, scarcely comprehending what materialized before them. An American Lightning, intact and operational, rolling to a stop on their airfield as casually as if returning from a training flight. One quick-thinking airman immediately drove a maintenance vehicle directly in front of the aircraft's nose, blocking any possibility of the pilot realizing his catastrophic navigation error and attempting an escape back into friendly skies. Within hours, Tenente Colonnello Angelo Tondi, chief test pilot of the Regia Aeronautica, would climb into that cockpit and discover something that would profoundly disturb German and Italian fighter tacticians. The Americans had not simply built thousands of these unconventional twin-engine fighters through brute industrial capacity. They had engineered into every Lightning a weapons system that fundamentally changed the mathematics of aerial combat. 450 caliber M2 Browning machine guns firing 2,000 rounds per minute, combined with 120mm Hispano cannon delivering 100 explosive shells per minute, all clustered in the nose and firing in perfect parallel alignment. No wing-mounted guns requiring harmonization at preset ranges. No complex deflection calculations needed to compensate for convergence points where separated streams of bullets might meet. Just pure, concentrated firepower along a single predictable trajectory that German test pilots would reluctantly admit created a killing zone extending reliably to 1,000 yards. The story of how captured enemy aircraft became instruments of uncomfortable revelation begins not with this single mistaken landing in Sardinia, but with the escalating air war across multiple theaters and the desperate Axis need for accurate intelligence about American fighter capabilities that transcended the chaos of combat reports. By mid-1943, both German and Italian air forces faced mounting pressure from American fighter bombers, whose true performance characteristics remained partially mysterious despite hundreds of encounters. The P-38 Lightning represented everything that German fighter doctrine had dismissed as theoretically unsound. Twin engines on a single-seat fighter seemed inefficient and unnecessarily complex, when excellent single-engine designs like the Messerschmitt Bf-109 and Focke-Wulf FW-190 had proven devastatingly effective across every theater. The radical twin-boom configuration appeared ungainly and violated established aerodynamic principles that emphasized compact, streamlined airframes. The tricycle landing gear contradicted decades of conventional tail-dragger design that every Air Force had perfected through extensive operational experience. Yet, this unconventional machine was appearing in ever greater numbers over North Africa, the Mediterranean, and increasingly over occupied Europe itself. Intelligence reports provided conflicting assessments of the Lightning's capabilities. Some combat pilots described it as fast but unmaneuverable, vulnerable in turning fights where experienced Axis pilots could exploit superior turn rates. Others reported the Lightning as nearly impossible to catch once its pilot chose to disengage, accelerating away with alarming speed while climbing to altitudes where German and Italian fighters labored with reduced power and degraded handling. The concentrated nose armament troubled Luftwaffe tactical analysts who studied gun camera footage and combat reports. Traditional wing-mounted armament required careful harmonization, where left and right-wing guns converged at a predetermined distance, typically 200 to 400 yards, creating an optimal killing zone. Beyond that convergence point, the separate bullet streams diverged again, dramatically reducing hit probability. Pilots learned to maneuver their aircraft to place targets within that optimal range envelope, accepting that firing outside the harmonization zone wasted precious ammunition and reduced effectiveness. The Lightning eliminated that fundamental limitation entirely through its revolutionary armament layout. All guns mounted in the nose, clustered around the cannon in a tight grouping that fired perfectly parallel. The bullet streams never converged and never diverged. They remained parallel across their entire effective range, creating a consistent cone of fire that extended far beyond the harmonization distances of wing-mounted weapons. If the pilot could see the target in his gun sight and the bullets could reach that distance aerodynamically, hits were possible. The harmonization problem simply disappeared through engineering elegance. German fighter pilots heard this characteristic described repeatedly in intelligence briefings throughout 1943, but abstract descriptions poorly conveyed the tactical reality. Explaining that American pilots could engage from greater distances told them nothing about what that actually meant in the split-second decisions of aerial combat. Statistics about parallel fire providing consistent accuracy at extended ranges remained mere numbers until experienced pilots felt the implications personally through direct, observation, or painful experience. The Regia Aeronautica's capture of an intact P-38G on June 12 provided the first opportunity for systematic axis evaluation of the Lightning under controlled conditions where every system could be examined. Methodically, every performance characteristic measured precisely, and every tactical implication analyzed carefully by pilots and engineers who understood fighter design and combat employment. German salvage operations across occupied territories had perfected the systematic recovery and evaluation of crashed Allied aircraft throughout the war. Specialized Bergebataillon, salvage battalions, operated with remarkable efficiency to secure crash sites, assess damage levels, and transport repairable aircraft to centralized testing facilities before advancing Allied forces could recapture the wrecks or local resistance movements could destroy them. The organizational structure reflected German military thoroughness, even as resources grew progressively scarcer and strategic circumstances deteriorated. The scale of Allied air operations over Europe and the Mediterranean made captures inevitable through statistical probability alone, with thousands of sorties flown monthly by American and British forces beginning in 1942 and accelerating dramatically through 1943. Mechanical failures, battle damage, navigation errors, fuel exhaustion, and weather-related incidents resulted in numerous forced landings on Axis-controlled territory. Some pilots executed controlled emergency landings that left their machines largely intact, recognizing that survival demanded accepting capture rather than attempting impossible flights to friendly territory in badly damaged aircraft. The Lightning that rolled to a stop at Capo Terra fell into this category of intact captures, though through navigation error rather than combat damage. The aircraft had sustained no battle damage, suffered no crash impact, and carried full fuel and ammunition loads. Italian recovery teams immediately recognized the extraordinary prize that fortune had delivered. This was not another crashed fighter to be stripped for intelligence and scrap metal. This was a complete, flyable example of American heavy fighter technology, ready for immediate exploitation. Italian technicians worked quickly to secure the aircraft and prepare it for the ferry flight to Guidonia Airfield, the Regia Aeronautica's primary testing and evaluation center, located approximately 15 miles northeast of Rome. Guidonia served as Italy's equivalent to Rechlin in Germany or Wright Field in the United States, where captured enemy aircraft underwent systematic evaluation by experienced test pilots and aeronautical engineers, who documented every detail for tactical intelligence reports distributed across operational units. Angelo Tondi, selected for this ferry flight due to his exceptional skill and extensive test pilot experience, approached the captured Lightning with professional curiosity mixed with considerable skepticism born from years of Italian aviation achievements. Official Italian assessments had consistently emphasized the superiority of Italian fighter design philosophy, particularly the elegant, lightweight, highly maneuverable fighters like the Macchi MC 202 and MC. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. 205 that prioritized dogfighting capability above all other considerations. The prevailing view among many Italian pilots, reinforced by official communications, held that American engineering focused on producing adequate quantities of acceptable aircraft rather than pursuing the performance excellence and refined handling that characterized the best Italian designs. These comfortable assumptions began dissolving rapidly the moment Tondi climbed into the Lightning's cockpit and experienced firsthand what American designers had actually achieved through unconventional thinking and willingness to challenge established doctrine. The cockpit layout immediately impressed Italian engineers familiar with the cramped, Spartan accommodations of Italian fighters, where every cubic centimeter was sacrificed to minimize weight and drag. The Lightning demonstrated thoughtful ergonomic design, with controls logically arranged and positioned within comfortable reach, reducing pilot workload and allowing concentration on tactical situations rather than struggling with aircraft systems. Instruments were clearly marked with easily readable gauges manufactured to tight tolerances that suggested quality control in American factories. The gun sight mounted centrally provided an unobstructed view forward, with the distinctive twin booms and engines positioned far enough outboard that they barely intruded into the pilot's peripheral vision. Most surprisingly, the spacious cockpit allowed room to move, shift position, and access various controls without the contortionist flexibility required in Italian single-engine fighters, where pilots essentially wore the aircraft like a tight suit. Visibility from the P-38's cockpit exceeded expectations dramatically. The tricycle landing gear meant the aircraft sat level on the ground, providing clear sight lines forward during taxiing without the blind spots inherent in tail draggers, whose nose-up attitude blocked forward vision until airborne. The framed canopy offered good visibility in most directions, though the twin booms and engines created blind spots directly below and to the sides that required conscious head movement to check. The true revelation came during the ferry flight from Capoterra to Guidonia, as Tondi advanced the throttles and felt both Allison V17-10 engines respond with smooth, progressive power delivery. The counter-rotating propellers eliminated the torque effects that single-engine fighters struggled with during takeoff and landing, particularly at high power settings. The aircraft accelerated down the runway with remarkable stability, requiring only gentle rudder inputs to maintain heading rather than the aggressive footwork needed to counter torque in conventional designs. Rotation occurred smoothly at the calculated airspeed, and the Lightning lifted off with authority that reflected its substantial power-to-weight ratio. Both engines produced 1,150 horsepower each at rated altitude, providing 2,300 total horsepower to accelerate a fighter that weighed approximately 14,000 pounds empty and could reach 21,000 pounds fully loaded. This represented considerably more power than single-engine fighters could generate, translating directly into performance advantages in acceleration, climb rate, and sustained speed. Once airborne, the Lightning demonstrated handling characteristics that challenged Italian preconceptions about twin-engine fighter viability. The flight controls responded crisply to inputs without the sluggishness Italian pilots expected from a heavy twin-engine machine. Aileron response proved particularly impressive, allowing roll rates that approached single-engine fighter performance despite the Lightning's greater wingspan and weight. The elevators provided positive pitch control throughout the speed range, and the rudders offered sufficient authority for coordination during aggressive maneuvering. The counter-rotating propellers created unexpected benefits beyond eliminating torque. In single-engine fighters, the propeller's rotation induced asymmetric airflow across the fuselage and control surfaces, creating handling quirks that pilots learned to manage through experience and compensation. The Lightning's props rotated in opposite directions, with the left engine turning counterclockwise and the right engine turning clockwise when viewed from the pilot's position. This arrangement meant that asymmetric effects from one propeller cancelled those from the other, resulting in balanced, predictable handling that simplified pilot workload. Tondi explored the aircraft's performance envelope carefully during the flight to Guidonia, testing acceleration, deceleration, turns at various bank angles, and climbs to different altitudes. Maximum speed exceeded 400 miles per hour at optimal altitude, substantially faster than the MC. 202's approximately 370 miles per hour. Climb rate impressed him considerably, with the Lightning reaching 15,000 feet in approximately 6 minutes despite carrying full fuel and ammunition. Service ceiling exceeded 38,000 feet, where the turbocharged Allison engines continued producing substantial power even as the progressively thinner air severely degraded performance in Italian fighters equipped with single-stage superchargers. The turbo-superchargers represented sophisticated engineering that German and Italian aeronautical engineers studied with particular interest. Each Allison engine featured a General Electric turbo-supercharger mounted in the upper rear portion of the boom, driven by exhaust gases that would otherwise dissipate uselessly into the atmosphere. The turbine extracted energy from the high-velocity exhaust stream and used that energy to drive a centrifugal compressor that forced additional air into the engine, maintaining manifold pressure and power output at altitudes where normally aspirated engines gasped for insufficient oxygen. This sophisticated forced induction system allowed the Lightning to maintain combat power above 30,000 feet, a critical advantage when engaging bomber formations that typically operated between 25,000 and 30,000 feet for protection against anti-aircraft fire, while remaining below altitudes, where crew oxygen requirements and equipment reliability became critically problematic. Italian interceptors struggled increasingly to reach these altitudes with sufficient performance to attack effectively, their engines producing only a fraction of rated power in the thin air, while Lightning escorts maintained speed advantage and maneuverability. After Tondi's successful ferry flight, the captured Lightning underwent comprehensive evaluation at Guidonia throughout late June and July 1943. Italian engineers and test pilots approached the examination with professional thoroughness, determined to extract every possible tactical insight from this unprecedented opportunity to study American fighter design philosophy directly. The armament installation attracted immediate attention from Italian pilots and weapons specialists who understood that fighter effectiveness ultimately depended on converting flight performance into actual enemy aircraft destroyed. The P-38s nose-mounted weapons cluster represented the most radical departure from conventional fighter design that Italian evaluators encountered during their examination. Traditional Italian and German fighters mounted machine guns in the fuselage, firing through the propeller arc via synchronization gear that prevented bullets from striking the whirling blades. This arrangement placed guns conveniently near the cockpit for easy access during maintenance and reloading, but created significant limitations. The synchronization mechanism itself wasted approximately 25% of potential fire rate because the interrupter gear prevented firing whenever a propeller blade crossed the gun's line of fire. Additionally, mounting multiple guns in the narrow fuselage nose restricted the number and caliber of weapons that could be physically accommodated. Wing-mounted armament solved the quantity and caliber limitations by distributing guns across the wingspan, where space allowed mounting numerous weapons and generous ammunition supplies. But wing mounting created the harmonization problem that plagued every air force. Left-wing guns and right-wing guns fired from different positions, creating separate bullet streams that only converged at the predetermined harmonization distance. At closer ranges, the streams remained too widely separated for multiple hits on small fighter targets. Beyond harmonization range, the streams diverged again, dramatically reducing hit probability. Pilots learned to maneuver to place targets within that optimal convergence zone, accepting reduced effectiveness at other distances. The Lightning's concentrated nose armament eliminated both problems simultaneously through elegant mechanical packaging made possible by the twin-boom configuration. With engines mounted far outboard in separate booms, the central nacelle offered an entire nose section dedicated exclusively to weapons and ammunition storage. 450 caliber M2 Browning machine guns mounted in a staggered vertical arrangement, with muzzles protruding from the nose in different lengths, to ensure straight ammunition belt feeds that prevented jamming. The 20mm Hispano cannon occupied the central position, firing through an opening directly below the pilot's feet. This concentration of firepower produced devastating effects that German and Italian test pilots verified through firing trials at ground targets. All 5 weapons fired along perfectly parallel trajectories, never converging and never diverging. The bullet streams remained parallel across their entire effective range, creating a consistent cone of fire approximately 3 feet in diameter that extended to maximum ballistic range. Unlike wing-mounted guns, where only a fraction of bullets struck the target depending on range and harmonization, the Lightning placed every bullet and cannon shell within that 3-foot circle if the pilot aimed correctly. Hit probability calculations told a dramatic story. At 400 yards, the typical harmonization distance for wing-mounted guns, conventional fighters achieved optimal hit rates. The Lightning matched this performance easily, but at 800 yards, wing-mounted guns had separated so far that perhaps 10 to 15% of takeout bullets struck typical fighter targets. The Lightning still placed 100% of its fire within the target area, limited only by ballistic drop and pilot aim rather than harmonization geometry. At 1,000 yards, wing-mounted guns became largely ineffective, with widely separated bullet streams rarely hitting anything smaller than bomber formations. The Lightning remained lethal, its parallel fire still concentrated in a killing zone small enough to ensure multiple hits on fighter targets. Italian test pilots firing captured American .50 caliber ammunition at ground targets verified these calculations through direct measurement of bullet impact patterns at various distances. The implications disturbed Italian and German tactical planners who understood aerial combat dynamics. Traditional fighter doctrine emphasized closing to point-blank range, accepting the vulnerability during approach in exchange for devastating effect at ranges of 200 yards or less, where even mediocre marksmanship guaranteed hits. Skilled pilots learned to hold fire until they could see every detail of the enemy aircraft, waiting until collision seemed inevitable before pressing the trigger and pouring concentrated fire into the target. This doctrine assumed that both attackers and defenders possessed roughly equivalent effective firing ranges, creating mutual vulnerability during approach. The attacker accepted defensive fire while closing, betting that he could reach optimal firing position before sustaining fatal damage. The defender attempted to damage the attacker sufficiently during approach to force breakaway before the attacker achieved killing position. The Lightning changed this equation fundamentally by extending effective range far beyond what wing-mounted weapons could achieve. American pilots could engage from 800 to 1,000 yards, distances where return fire from conventional fighters rarely achieved hits. This created a tactical window where Lightning pilots could fire effectively while remaining effectively immune to return fire. German and Italian pilots found themselves under accurate attack at ranges where their own weapons delivered only scattered, ineffective fire. The psychological impact of this capability exceeded its raw effectiveness in many engagements. Axis pilots instinctively recognized maximum effective range through extensive combat experience, learning through survival which distances offered reasonable hit probability. When tracer fire converged accurately from beyond those familiar ranges, pilots experienced cognitive dissonance that disrupted tactical decision-making. Their experience told them the range was excessive, yet the evidence of their eyes showed accurate fire achieving hits at impossible distances. Many pilots broke off attacks prematurely when facing Lightning fire, assuming incorrectly that the accurate fire at long range indicated they were actually much closer than their range estimation suggested. Rather than pressing attacks into what they believed was point-blank range, they disengaged from what they considered dangerously close quarters, inadvertently ceding tactical initiative to Lightning pilots who remained comfortably beyond the effective range of return fire. Luftwaffe tactical reports from North African operations during late 1942 and early 1943 documented this phenomenon repeatedly. German fighter pilots described approaching Lightning formations at what they judged to be safe distances for final positioning, only to encounter accurate fire that forced immediate evasive action and attack termination. After-action analysis revealed that these engagements occurred at 600 to 800 yards, distances where German wing-mounted weapons achieved minimal effectiveness, while Lightning nose armament remained devastatingly accurate. The technical intelligence gathered from the captured P-38G extended well beyond simple flight testing and combat evaluation. Italian engineers at Guidonia systematically disassembled components to understand American manufacturing techniques, material selections, and detailed design approaches that enabled mass production of such sophisticated aircraft. They examined the Allison V1710 engines with great interest, noting the sophisticated 12-cylinder V configuration that produced 1,150 horsepower at rated altitude through careful engineering rather than sheer displacement. The engines featured overhead camshafts, sodium-cooled exhaust valves, and precisely machined internal components that reflected tight manufacturing tolerances and quality control procedures. Italian engineers compared these characteristics to their own engine designs, recognizing areas where American metallurgy and precision manufacturing exceeded current Italian capabilities. The turbo-supercharger installation received particularly careful attention as Italian and German engineers attempted to understand how American designers had achieved such impressive high-altitude performance. The General Electric Type B2 turbo-supercharger represented years of American research into forced induction systems, incorporating sophisticated turbine designs and efficient compressor stages that extracted maximum energy from exhaust gases while maintaining reliability under extreme operating conditions. Each turbo-supercharger occupied the upper rear portion of its respective boom, positioned to receive hot exhaust gases directly from the engine, while maintaining sufficient separation to prevent heat-related damage to surrounding structure. The turbine wheel rotated at speeds exceeding 20,000 revolutions per minute, driven by exhaust energy that reached temperatures above 1,000 degrees Fahrenheit. The compressor section compressed ambient air and delivered it to the engine through ducting that incorporated an intercooler to reduce temperature and increase density for maximum power. German engineers noted repeatedly the consistently high quality of materials used throughout the aircraft. American access to strategic materials like high-grade aluminum alloys, specialized steels, and reliable rubber compounds allowed designers to create structures that effectively combined strength with acceptable weight while maintaining production efficiency. Italy faced increasingly severe material shortages by mid-1943, forcing the use of substitute materials that often proved inferior in strength, durability, or manufacturing characteristics. The investigation of the captured Lightning revealed sophisticated manufacturing techniques that enabled genuine mass production without significantly compromising quality standards. American factories produced P-38 seconds using highly developed assembly line methods that maintained remarkably tight tolerances and consistent quality across thousands of individual aircraft. Lockheed's Burbank facility alone eventually achieved production rates exceeding one aircraft per day at peak output during 1944, an achievement that seemed impossible to Italian observers accustomed to production rates measured in dozens per month using traditional methods. Italian production relied increasingly on skilled craftsmen, hand-fitting components through labor-intensive processes, an approach that delivered excellent quality but severely limited quantity. The Americans had successfully industrialized fighter production through extensive use of jigs, fixtures, and specialized tooling that allowed semi-skilled workers to assemble complex aircraft rapidly while maintaining acceptable quality. This represented a fundamental philosophical difference in manufacturing approach that Italy could not replicate given resource constraints and industrial organization. On August 11, 1943, Angelo Tondi demonstrated the captured Lightning's combat capability in the most direct manner possible. American bomber formations approached from the south that morning, returning from bombing operations against Terni in Umbria. Italian radar tracking detected the formations early enough to allow Tondi to take off from Guidonia and climb to intercept altitude, using the Lightning's impressive climb rate and turbo-supercharged high-altitude performance. American bomber gunners saw what appeared to be a friendly P-38 approaching their formation from an unexpected angle, naturally assuming it represented an escort fighter that had become separated from its unit and was returning to the protective coverage of the bomber stream. No defensive fire targeted the approaching Lightning as it closed steadily from a favorable position, its distinctive silhouette creating perfect camouflage through assumed friendly identity. Tondi pressed his attack to optimal firing range, approximately 600 yards, where the concentrated nose armament delivered maximum effectiveness. He centered the gun sight Pipper on a B-24 Liberator near the formation's edge and pressed the firing button mounted conveniently on the control yoke's grip. 4 50 caliber machine guns and one 20mm cannon erupted simultaneously, sending a parallel stream of projectiles into the bomber's fuselage and wing section. The effect was devastating and nearly immediate. Multiple 50 caliber rounds and at least 3 explosive 20mm shells struck the B-24's left wing near the No. 2 engine, severing fuel lines and initiating a fire that quickly spread through the wing structure. The bomber fell away from the formation trailing flame and smoke, rolling inverted as its left wing failed structurally. 6 crewmen successfully bailed out, their parachutes blooming white against blue Mediterranean sky as they descended toward the coastline near Torvajanica. The engagement lasted perhaps 15 seconds from initial trigger depression until the bomber's structural failure, testament to the Lightning's concentrated firepower and Tondi's marksmanship. But this combat success also marked the captured P-38G's final operational mission, Italian aviation fuel, refined using different processes from American gasoline, contained chemical impurities and additives that reacted corrosively with the aluminum alloy fuel tanks in the Lightning's wings and center section. After Tondi's combat sortie, Italian ground crews discovered severe corrosion damage inside the fuel system during post-flight inspection. The tanks showed pitting and chemical etching that would eventually cause leaks and structural failure if flight operations continued using Italian fuel. Without access to proper American aviation gasoline or suitable replacement tanks manufactured to American specifications, the captured Lightning was effectively grounded. Italian engineers attempted various solutions, including coating tank interiors with protective sealants, but none proved satisfactory for sustained operations. The Lightning sat idle at Guidonia through late August and early September 1943 as Italian military and political circumstances deteriorated rapidly. Allied forces had landed in Sicily on July 10th and advanced steadily across the island despite determined resistance. The Italian government, recognizing defeat was inevitable, opened secret negotiations with Allied representatives regarding armistice terms. On September 8th, Italy announced its capitulation and withdrawal from the Axis alliance, transforming overnight from German ally to co-belligerent with the Allies. German forces, anticipating Italian defection, had prepared contingency plans to seize control of critical Italian military installations, equipment, and strategic locations before Allied forces could capitalize on the armistice. Wehrmacht units moved swiftly to occupy Guidonia and other Italian air facilities, securing aircraft and technical documentation before Italian personnel could evacuate or destroy sensitive materials. The captured P-38G at Guidonia fell into German hands during this rapid takeover, joining other Italian aircraft and equipment now controlled by the Luftwaffe. German recovery teams immediately recognized the value of the intact Lightning, despite its grounded status due to fuel system corrosion. The aircraft represented an opportunity for German test pilots and engineers to conduct their own evaluation of American fighter capabilities, supplementing intelligence gathered from other captured examples through different circumstances in other theaters. The Lightning received new German markings, its fuselage bearing the Luftwaffe code T9+XB, with bright yellow paint applied to the tail surfaces and undersides, for easy identification by German pilots and anti-aircraft gunners who might otherwise mistake it for an enemy aircraft during flight operations or ground movements. This yellow identification scheme followed standard Luftwaffe procedures for captured Allied aircraft operated by evaluation units, creating immediate visual distinction that prevented friendly fire incidents. German plans called for transporting the Lightning to Rechlin, the Luftwaffe's primary testing facility located approximately 100 kilometers northwest of Berlin in Mecklenburg, where it would undergo repairs to address the fuel system corrosion and receive comprehensive evaluation by experienced German test pilots. However, the aircraft never completed this journey. Records indicate the Lightning was destroyed during Allied bombing raids against Guidonia on June 1st and 3rd, 1944, caught outside its protective hangar and reduced to wreckage by explosive and incendiary bombs that left little salvageable material. The loss represented a significant intelligence setback for German evaluation programs, as systematic testing by Luftwaffe pilots would have provided valuable comparative data between the Lightning and German fighter types under controlled conditions. But German forces had already obtained access to other P-38 examples through different capture circumstances, ensuring that Lightning evaluation continued despite the destruction of the Italian aircraft. Hans Werner Lersch, the Luftwaffe's most experienced test pilot of captured Allied aircraft, noted in his post-war memoir that he never received opportunity to fly a Lightning during his extensive service at Rechlin and other test facilities. He referenced a captured P-38 that crashed before he could conduct evaluation flights, possibly referring to an aircraft that arrived damaged or suffered accident during initial German test flights by other pilots. The incomplete historical record makes definitive identification of specific captured Lightnings difficult, as documentation was lost, destroyed, or scattered across archives during Germany's final collapse. What remains clear from surviving records is that German tactical intelligence regarding the P-38 Lightning improved dramatically throughout 1943 and 1944 through combat experience, captured examples when available, and systematic analysis of wreckage recovered from crash sites across occupied territories. German fighter pilots received increasingly detailed briefings about Lightning capabilities, tactical employment, and specific vulnerabilities that could be exploited by skilled pilots using proper tactics. The concentrated nose armament feature prominently in these tactical assessments, with German intelligence officers emphasizing repeatedly the extended effective range that American pilots could achieve through parallel fire. Luftwaffe tactical bulletins distributed to operational fighter units throughout late 1943 specifically warned pilots against approaching Lightnings from dead astern at ranges exceeding 400 meters, noting that American pilots could engage effectively at distances where return fire from German wing-mounted weapons achieved minimal results. These bulletins recommended frontal or high deflection attacks that minimized exposure time in the Lightning's fire cone, while maximizing German fighter advantages in instantaneous turn rate and roll performance at low speeds. German pilots learned through painful experience that sustained pursuit attacks against Lightnings rarely succeeded unless the American pilot made tactical errors or suffered mechanical problems that prevented full exploitation of the aircraft's performance envelope. The Lightning's twin-engine configuration provided survival advantages that single-engine German fighters could never match. Luftwaffe pilots discovered repeatedly that battle damage sufficient to destroy one engine often left the Lightning capable of controlled flight and even continued combat on the remaining engine. The counter-rotating propeller arrangement meant that losing either engine produced manageable asymmetric thrust that pilots could counter with rudder input and slight aileron deflection. German combat reports documented numerous engagements where Lightnings sustained severe damage to one engine through cannon fire or anti-aircraft hits, yet continued flying long enough to reach friendly territory or achieve controlled crash landings that allowed crew survival. Single-engine German fighters offered no such redundancy. Any damage that disabled the sole power plant transformed the aircraft into an unpowered glider with extremely limited options and high probability of pilot death or serious injury. This fundamental survivability advantage contributed significantly to American pilot confidence in the Lightning, particularly during long overwater missions in the Mediterranean and Pacific theaters, where engine failure meant almost certain death without backup power. Pilots knew they could survive mechanical failures or battle damage that would prove fatal in single-engine aircraft, encouraging more aggressive tactics and willingness to press attacks despite defensive fire. The P-38's long-range capability troubled German commanders even more than its armament characteristics. German fighter doctrine emphasized relatively short-range interception missions where aircraft operated within 200 kilometers of their bases, allowing multiple sorties per day and simplified logistics. The Lightning routinely operated at combat radii exceeding 800 kilometers with external drop tanks, more than quadruple the effective range of Bf-109Gs and Fw-190As under comparable combat conditions. This massive range advantage fundamentally transformed escort operations in ways that proved strategically decisive across multiple theaters. Early in the Mediterranean campaign, German fighters could wait until shorter-range American escorts reached their fuel limits and turned back toward their bases, then attack bomber formations during the most vulnerable portions of their missions deep in Axis-controlled territory. The Lightning's extraordinary range eliminated this tactical window entirely. American escorts could now accompany bombers throughout complete missions, regardless of target distance, preventing German fighters from ever finding truly unprotected targets. The strategic implications were profound and deeply troubling to Luftwaffe commanders, who understood that German fighters now had to fight their way through escorts to reach bombers, dramatically increasing risk and reducing interception effectiveness. Production statistics told a devastating story about relative industrial capacity that German intelligence analysts understood but could do nothing to counter. By mid-1944, Lockheed's Burbank facility was producing approximately 1 P-38 per day at peak output, with total American Lightning production eventually exceeding 10,000 aircraft across all variants between 1941 and 1945. This output represented more than 3 times the combined production of all German twin-engine fighters, including the Messerschmitt Bf 110 and its successor designs. German twin-engine fighter programs consistently struggled with doctrinal uncertainty, resource limitations, and competing priorities that prevented development of truly effective long-range escort fighters, or heavy fighters, comparable to the Lightning. The Bf 110, Germany's primary twin-engine fighter during the early war years, had proven vulnerable to modern single-engine fighters, despite respectable performance in other roles. Subsequent designs never achieved production quantities sufficient to influence strategic outcomes. The fundamental philosophical difference revealed itself through these production disparities. American doctrine embraced the twin-engine fighter concept early, accepting slightly reduced dogfighting performance in exchange for extended range, heavy armament, and twin-engine survivability. German doctrine remained wedded to single-engine fighter primacy, treating twin-engine designs as specialized aircraft for specific roles rather than mainstream fighter types suitable for air superiority missions. This doctrinal commitment to single-engine fighters reflected reasonable tactical logic based on European theater geography, where relatively short distances separated air bases from likely combat zones. But it proved catastrophically short-sighted when the war expanded to include global operations over vast oceanic expanses, where range became the paramount requirement. The Lightning excelled in exactly these environments, dominating Pacific theater operations, where its long range allowed missions that simply exceeded the physical capabilities of shorter-range opponents. American pilot Richard Bong, who became the United States' top-scoring ace with 40 confirmed aerial victories, achieved every one of those kills while flying P-38 Lightnings in the Pacific theater. His success demonstrated how skilled pilots could fully exploit the Lightning's unique combination of range, speed, firepower, and twin-engine reliability to achieve combat dominance, despite the aircraft's acknowledged limitations in slow-speed maneuvering combat. Bong's tactical approach emphasized the Lightning's strengths while carefully avoiding situations where Japanese fighters held advantages. He utilized superior speed and climb rate to control engagement geometry, approaching from advantageous positions and maintaining energy throughout combat. He employed the concentrated nose armament to engage from extended ranges, where return fire proved ineffective. He relied on twin-engine reliability during long over-water missions that routinely exceeded 600 miles from base to combat zone and back. German intelligence services monitored American ace achievements through various sources, including intercepted radio transmissions, prisoner interrogations, and captured documents. Reports of Lightning pilots achieving multiple victories per mission while operating at extreme ranges from their bases troubled German tactical analysts, who recognized similar capabilities would prove devastatingly effective in the European theater if American forces concentrated Lightning units there in significant numbers. The 8th Air Force in England initially received 4 Lightning groups during late 1943 and early 1944 for bomber escort operations over Germany. These units encountered significant operational challenges that reduced Lightning effectiveness in the European theatre compared to its stellar performance in the Pacific and Mediterranean. The problems stemmed primarily from environmental factors rather than fundamental aircraft deficiencies. High-altitude operations over northern Europe occurred in drastically colder conditions than Mediterranean or Pacific environments. At 25,000 to 30,000 feet over Germany during winter months, outside air temperatures regularly reached -40 to -50 degrees Fahrenheit, far colder than pilots experienced over warmer theatres. The Lightning's cockpit heating system, designed primarily for moderate temperature differentials, proved grossly inadequate for these extreme conditions. Pilots suffered terribly from cold exposure during extended missions lasting 4 to 6 hours. Their hands and feet became numb, despite electrically heated flight suits that often malfunctioned or provided insufficient warmth. Frostbite injuries became common among Lightning pilots flying bomber escort missions over Germany, with some pilots requiring medical treatment and temporary grounding after missions due to cold-related injuries. The extreme cold also affected engine reliability and performance in unexpected ways. The Allison engines and their associated systems had been developed primarily for moderate climate operations and tested extensively in California's temperate environment. When operated continuously at -40 degrees or colder, oil viscosity increased dramatically despite specification of winter-grade lubricants, reducing lubrication effectiveness and increasing internal friction. Fuel volatility decreased, causing carburetor icing and irregular combustion. Various seals and gaskets contracted differently than their metal surroundings, creating leak paths and pressure losses. These cold-related problems appeared with increasing frequency during winter missions over Germany, forcing many Lightnings to abort missions due to mechanical issues and reducing the effective number of aircraft completing escort assignments. German fighter pilots quickly learned to recognize Lightning formations that appeared to be experiencing mechanical difficulties, targeting struggling aircraft for preferential attack. Additionally, the turbo superchargers that provided such impressive high-altitude performance proved temperamental in extreme cold, occasionally failing to maintain proper boost pressure or suffering control problems that limited power output at critical moments. When turbo supercharger problems occurred simultaneously with combat maneuvering demands, pilots found themselves flying heavy twin-engine fighters with insufficient power, creating dangerous vulnerability to attack by lighter, more agile German single-engine fighters. Despite these significant operational challenges, Lightning pilots achieved respectable combat results in the European theatre when weather and mechanical reliability allowed full exploitation of the aircraft's capabilities. The concentrated nose armament proved just as effective against German aircraft as it had against Japanese and Italian opponents, delivering devastating firepower at extended ranges that German pilots found difficult to counter. Robin Olds, who would later achieve fame commanding fighter operations in Vietnam, scored his first 5 aerial victories while flying P-38 seconds with the 8th Air Force in 1944. His experiences demonstrated that skilled pilots could overcome the Lightning's European theatre challenges through superior tactics and aggressive employment. Olds emphasized maintaining speed and energy throughout engagements, refusing to be drawn into slow-speed turning fights where German fighters held clear advantages in instantaneous turn rate and low-speed handling. His tactical approach mirrored lessons that Pacific Lightning pilots had learned through extensive combat experience against highly maneuverable Japanese fighters. The key to Lightning's success lay in disciplined energy management, using superior speed and climb rate to dictate engagement terms while avoiding situations where the aircraft's greater weight and wing loading became tactical liabilities. German test pilot evaluations of captured or examined Lightning wreckage consistently emphasized the same tactical assessment. In reports distributed to operational fighter units, Luftwaffe intelligence stressed that the P-38 could not outturn the Bf-109 or Fw-190 in sustained horizontal turns at moderate speeds and altitudes. German pilots who forced Lightnings into these turning engagements could achieve advantageous positions for gun solutions, particularly if American pilots made the tactical error of accepting slow-speed turning combat. However, German reports also acknowledged candidly that Lightning pilots who maintained disciplined energy tactics remained extremely difficult to engage effectively. The combination of speed advantage and superior climb rate allowed competent Lightning pilots to refuse disadvantageous engagements entirely, accelerating away from pursuing German fighters that lacked sufficient speed to force continued combat. German pilots discovered repeatedly that they could not compel Lightning pilots to fight on German terms if the American chose to disengage. This fundamental tactical reality frustrated German fighter leaders who understood that defensive operations required forcing combat on enemy formations rather than allowing attackers to select optimal conditions. When escorting fighters could choose whether to engage or disengage based on tactical assessment, defensive interceptors lost the initiative and struggled to achieve their primary mission of preventing bomber attacks on German industrial and military targets. The concentrated nose armament figured prominently in German tactical recommendations for engaging Lightnings. Luftwaffe bulletins specifically warned against head-on attacks unless pilots possessed exceptional nerve and accurate gunnery skills. The technical reasoning was simple and compelling. Head-on attacks against aircraft with wing-mounted guns created mutual vulnerability, where both fighters exposed themselves to enemy fire during the brief engagement window. But head-on attacks against Lightnings created asymmetric vulnerability that heavily favored the American aircraft. The Lightning's pilot aimed the entire aircraft at the target, knowing that all weapons fired along the aircraft center line. German pilots had to aim carefully to achieve proper convergence with wing-mounted weapons, then maintain that precise aim while watching a multi-gun battery and 20mm cannon pointing directly at them and firing accurately at ranges exceeding 800 meters. The psychological pressure of watching tracer fire converge from that tightly clustered nose armament proved overwhelming for many German pilots, who broke off head-on passes prematurely before achieving optimal firing position. Those German pilots who maintained attack discipline until reaching proper firing range often paid with their lives, as the Lightning's parallel fire achieved high hit probability even during the brief window when both aircraft fired at each other. Luftwaffe tactical recommendations therefore emphasized beam attacks and high deflection shots that minimized exposure time in the Lightning's fire cone. These tactics required considerable skill to execute properly, as pilots had to calculate proper lead angles while maneuvering at high speed and maintaining awareness of other threats. Less experienced German pilots struggled to master these demanding techniques, particularly during the final 2 years of the war, when training time decreased dramatically due to fuel shortages and compressed pilot production schedules. By late 1944, the average German fighter pilot arriving at frontline units possessed barely 100 hours total flight time and minimal combat training, having progressed through abbreviated courses that sacrificed depth for speed in desperate attempts to replace mounting losses. These inadequately prepared pilots faced veteran American Lightning pilots with hundreds of hours of combat experience who understood how to exploit every advantage their aircraft provided. The resulting combat attrition told a grimly predictable story reflected in loss statistics. German fighter units suffered unsustainable casualties during defensive operations against American bomber streams escorted by Lightnings and other long-range fighters. Experienced pilots who understood through hard-won combat experience how to fight effectively against Lightnings were killed or seriously wounded, faster than replacement pilots could be trained, even under the compressed and inadequate training programs. New pilots with minimal preparation survived only a handful of missions on average before being shot down, often achieving nothing of tactical value before their deaths. The Luftwaffe hemorrhaged its most valuable and irreplaceable asset: skilled, experienced pilots with the knowledge and judgment necessary for survival and effectiveness at rates that could not possibly be sustained regardless of aircraft production rates or fuel availability. The captured Italian P-38G that ended its operational career grounded by fuel system corrosion had nevertheless provided Italian and subsequently German intelligence services with valuable insights about American fighter capabilities. The brief combat success achieved by Angelo Tondi demonstrated conclusively that the Lightning posed a formidable threat when flown by skilled pilots who understood its capabilities. The concentrated nose armament that enabled accurate fire at 1,000 yards represented genuine tactical innovation that challenged fundamental assumptions about optimal fighter design. German aeronautical engineers who examined lightning wreckage and studied technical intelligence reports developed grudging professional respect for American engineering approaches, despite their position as enemies. They recognized that Lockheed's designers had created a coherent weapon system that deliberately sacrificed some characteristics to optimize others based on clearly defined mission requirements. The Lightning traded some dogfighting agility for extended range, heavy concentrated firepower, and twin-engine survivability, a reasonable engineering compromise that served American strategic requirements effectively. The nose-mounted armament represented the Lightning's most revolutionary contribution to fighter design evolution. By concentrating all weapons in a tight cluster firing along parallel trajectories, American designers eliminated the harmonization problem that had plagued every previous fighter design using wing-mounted guns. This seemingly simple solution required the unconventional twin-boom configuration that German designers had dismissed as unnecessarily complex, demonstrating how willingness to challenge orthodoxy sometimes produced breakthrough innovations. The tactical implications extended far beyond simply hitting targets at longer ranges. The parallel fire provided consistent effectiveness across the entire engagement envelope, from point-blank range to maximum ballistic distance. Pilots could engage at whatever range tactical circumstances demanded without worrying about whether that distance fell within optimal harmonization zones. This flexibility reduced pilot workload during the intense concentration demands of aerial combat, allowing focus on tactics and situational awareness rather than range estimation for optimal weapons employment. German test pilots who examined captured examples or studied combat film consistently noted the buzzsaw effect that concentrated lightning fire produced. The parallel stream of 450 caliber machine guns and one 20mm cannon created a cone of fire approximately 3 feet in diameter that literally cut through target aircraft when sustained on target for even brief periods. Bomber formations experienced this effect most dramatically, with lightning attacks severing control surfaces, destroying engines, and creating catastrophic structural damage far more efficiently than dispersed fire from wing-mounted weapons. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe. The legacy of the Lightning's concentrated nose armament influenced post-war fighter design significantly, though not always in immediately obvious ways. The advent of jet propulsion eliminated many constraints that had driven piston-engine fighter design, allowing engineers to reconsider fundamental assumptions about optimal weapon placement and configuration. Many early jet fighters adopted nose-mounted armament arrangements similar to the Lightning, recognizing the tactical advantages of concentrated parallel fire. The North American F-86 Sabre, America's primary jet fighter during the Korean War, mounted 650 caliber machine guns in the nose, clustered tightly around the aircraft centerline. This arrangement provided the same advantages that Lightning pilots had exploited a decade earlier. Consistent accuracy across the entire engagement range, simplified aiming that required only pointing the aircraft at the target, and devastating concentrated firepower that maximized hit probability and damage per engagement. Soviet designers reached similar conclusions through independent analysis, mounting cannon armament in nose or fuselage centerline positions on their early jet fighters rather than distributing weapons across wing installations. The MiG-15, which opposed American Sabres over Korea, featured two 23mm and one 37mm cannon clustered near the aircraft nose, creating concentrated firepower that could destroy enemy aircraft with brief bursts when properly aimed. These design choices vindicated the Lightning's revolutionary approach to fighter armament, demonstrating that concentrated nose-mounted weapons provided genuine tactical advantages that transcended specific aircraft configurations or propulsion technologies. The fundamental physics of parallel fire, creating consistent accuracy across extended ranges, remained valid, regardless of whether aircraft flew at 300 miles per hour or 600 miles per hour. The Lightning's other innovations proved similarly influential on post-war fighter development. The twin-boom configuration itself fell out of favor, as jet engines eliminated the need to accommodate propeller arcs and allowed more conventional fuselage layouts. But the underlying principle that unconventional designs sometimes offered significant advantages despite violating established conventions became widely accepted in the jet age when numerous radical configurations appeared as designers explored new possibilities. The tricycle landing gear that had seemed so unconventional on the Lightning became universal standard for jet fighters within a few years. The improved visibility during ground operations, better directional stability during takeoff and landing, and reduced propensity for ground loops convinced every Air Force that tricycle configurations offered clear advantages over traditional taildragger arrangements. By 1950, virtually every new fighter design incorporated tricycle landing gear, completing the transition that the Lightning had pioneered during the late 1930s. The captured P-38G that landed mistakenly at Capoterra on June 12, 1943, had an extraordinary if brief operational career. From an American fighter on a routine ferry mission to an Italian evaluation aircraft to a combat striker that destroyed an American bomber, and finally to German possession before destruction in Allied bombing raids, the aircraft demonstrated through its journey the increasingly global and interconnected nature of World War II aerial warfare. That single Lightning taught Italian and German pilots and engineers valuable lessons about American design philosophy, manufacturing capability, and tactical innovation. The concentrated nose armament that could engage accurately at 1,000 yards forced Axis tactical planners to reconsider fundamental assumptions about optimal fighter combat ranges and engagement geometry. The extended range capability that allowed 800-kilometer combat radius made German defensive planning increasingly difficult, as American escorts eliminated the tactical windows that had previously existed for attacking unprotected bombers. But individual captured aircraft, however valuable for intelligence purposes, could not alter strategic outcomes determined by overwhelming material advantages and industrial capacity. German and Italian forces understood Lightning capabilities thoroughly by mid-1944 through combat experience and systematic study of captured examples. This knowledge provided limited practical benefit when they still had to engage these superior aircraft in defense of increasingly indefensible positions under direct orders, lacking the numbers, fuel, spare parts, and adequately trained pilots necessary to counter American advantages effectively. The story of captured Lightnings in Axis service illustrates the sophisticated and professional approach that both German and Italian forces took toward understanding enemy capabilities, despite deteriorating strategic positions. Rather than relying solely on fragmentary combat reports and intelligence assessments of uncertain reliability, Axis forces invested significant scarce resources in recovering, repairing when possible, and systematically examining captured American aircraft under controlled conditions. This systematic approach to tactical intelligence gathering represented best practices for military organizations seeking to understand opponent capabilities accurately and continued even as strategic situations became increasingly hopeless. German and Italian pilots who examined captured Lightnings gained valuable knowledge about aircraft characteristics and optimal tactics. But that hard-won knowledge primarily confirmed what many already suspected. American aircraft possessed significant performance advantages in categories that mattered strategically. The Lightning's concentrated nose armament, enabling accurate fire to 1,000 yards, was not the most important characteristic determining strategic outcomes. The massive American industrial capacity that produced over 10,000 Lightnings while simultaneously building comparable quantities of other fighter types proved far more decisive than any individual technical innovation. But the nose-mounted weapons exemplified American willingness to challenge conventional design assumptions in pursuit of tactical advantages, a philosophy that extended throughout their entire military aviation industry. German test pilots who studied captured Lightnings or examined wreckage came away acknowledging American engineering achievement while regretting the strategic implications. The concentrated firepower represented sophisticated integration of weapons, airframe design, and tactical doctrine into a coherent package optimized for specific mission requirements. This integration reflected mature design processes and willingness to make unconventional choices when technical analysis suggested advantages, despite violating established practice. The admission by Axis pilots that they had never encountered nose-mounted armament, achieving 1,000-yard accuracy, represented professional acknowledgement of American tactical innovation and realistic recognition of the significant advantages Lightning pilots enjoyed in combat operations. This acknowledgement, forced by direct experience with captured aircraft and painful combat encounters, illustrated how confronting uncomfortable realities sometimes requires direct personal experience that cannot be dismissed or explained away through ideological assumptions or wishful thinking. The Lightning flew operationally from 1941 through 1945, compiling an impressive combat record across every theater where American forces operated. It destroyed more Japanese aircraft than any other American fighter type in the Pacific, provided crucial long-range escort for Mediterranean bombing operations, and served adequately, if not optimally, in the challenging European theater environment. Over 10,000 aircraft produced, hundreds of pilots achieving ace status with 5 or more victories, and numerous critical missions accomplished, including the famous interception of Admiral Yamamoto. Yet, the Lightning remains somewhat overshadowed in popular memory by other American fighters, particularly the P-51 Mustang that eventually replaced Lightnings in European theater escort operations and the F-4U Corsair that dominated carrier operations in the Pacific. This relative obscurity seems unjust given the Lightning's genuine innovations and combat effectiveness. Perhaps the twin-boom configuration appeared too unconventional for enduring iconic status, or perhaps the specialized nature of long-range escort operations attracted less attention than dogfighting exploits in more dramatic combat scenarios. Whatever the reasons for its complicated legacy, the P-38 Lightning deserves recognition as one of World War II's most innovative and effective fighter designs. Its concentrated nose armament revolutionized fighter weapons installation and influenced jet-age designs that adopted similar configurations. Its long range enabled strategic missions that shorter-range fighters simply could not accomplish. Its twin-engine reliability saved countless pilots who survived engine failures or battle damage that would have proved fatal in single-engine aircraft. The captured Italian Lightning that flew briefly against its former compatriots demonstrated these characteristics conclusively through direct measurement and combat application. German and Italian pilots who encountered Lightnings throughout the war learned to respect the aircraft's capabilities while developing tactics to exploit its weaknesses. But respect and tactical knowledge could not overcome the fundamental advantages that American Lightning pilots enjoyed through superior range, concentrated firepower extending to 1,000 yards, and overwhelming numerical superiority as American industrial production outpaced Axis losses by increasingly dramatic margins. The Lightning's story, like that of so many World War II weapons systems, ultimately illustrated that individual technical excellence, while valuable and worthy of recognition, could not determine strategic outcomes alone. Wars were won through comprehensive application of industrial capacity, trained personnel, logistical excellence, and tactical competence across entire force structures, not through isolated examples of brilliant engineering or tactical innovation. But within that larger strategic narrative, the Lightning carved out a distinctive place through genuine innovation in fighter armament that challenged orthodoxy and proved demonstrably effective through thousands of combat engagements. The concentrated nose-mounted weapons firing in perfect parallel alignment to 1,000 yards represented American engineering at its creative best, solving fundamental problems through unconventional thinking and rigorous technical execution. That legacy endures long after the last Lightning flew its final mission, preserved in museums and technical archives that document one of aviation history's most distinctive and innovative fighter designs. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.